All right, so another carbon nucleophile. So we have learned Grignard reagent, cyanohydrin formation using cyanide. This one is Wittig reaction. So it looks like W, but we actually pronounce it as a V. Okay, named after George Wittig. Okay, he's a German chemist, and yeah, George doesn't have E at the end, right? And W is pronounced like V. So anyway, Wittig reaction. Let's take a look what happened. Some of you probably have some of you probably remember ozonolysis. Wittig reaction is a reverse of ozonolysis. Take a look right here. So if you remember ozonolysis, you start with an alkene and you cut this bond, adding ozone, you get aldehyde or ketone. Okay, this one in Wittig reaction, take aldehyde and ketone, adding carbon nucleophile on that carbon. Yeah, you pass through four-membered ring we call oxaphosphetane. Now, oxa means water. Oh, oxa means oxygen, so oxaphosphetane, and this ring break down and becomes just an alkene. So it's a reverse of Wittig reaction, and the byproduct is triphenyl phosphinoxide. Look at right here. Okay. All right, so let's take a look how it works in here. So in generally, so the in Wittig reaction, the nucleophile is called Ylide, or look, you can either write E at the end, but we call it Ylide. Please don't pronounce Ylide. That's so lame. don't, it's Ylide. Okay. All right, so we take Ylide, so the negative charge on carbon attack the carbon of the carbonyl carbon, and the oxygen will take the two pi electrons, attack the phosphorus, okay, to form a four-membered ring, oxaphosphetane, and this ring will undergo a retro 2+2 cycloaddition. Oh, I forget to mention the first step right here is just 2+2 cycloaddition. So 2 electron from carbon and a 2 electron from the pi electron of carbonyl. Okay, it's so make a ring basically. You probably are familiar with the 4+2 cycloaddition disorder, right? This one is 2+2, and the second step is a retro, which means going backward or breakdown using 2 electrons and to form the alkene product and triphenyl phosphinoxide. All right, so a little bit detail about Wittig reaction. So it's an extension of carbon chain. So one thing besides Grignard reagent, using alkyne, alkylation of alkyne, cyanide, or you can do Wittig reaction. All right, from it. And we form CC double bond, which is very, very unique. We never learned any reaction from alkene before. The reagent in Wittig reaction are pretty reactive, so we have to make a preparation in situ, which means that we make it in the reaction and use it immediately. Okay. And for example, like the Ylide right here, pretty reactive. So we make Ylide and we use it right away in the same reaction flask. Right. We'll talk about how to make it in a little bit. And this reaction is spontaneous, and the driving force is the formation of phosphorus oxygen double bond. This bond is pretty strong, right? That drive all equilibrium forward. So it favors the formation of the product, basically. All right, let's start with the Ylide. How do we make Ylide? Okay. Just like Grignard reagent, if you want to make Grignard, you have to make it first. So this is how we make Ylide. So we usually make Ylide from a simple alkyl halide, right? Not too sterically hindered, because the first step in the SN2, you can use tertiary in here. Okay. All right. So we take, let's say, I'll take a methyl primary or secondary alkyl halide, not tertiary. Phosphorus, which is a good nucleophile. Think about sulfur, right? So it's big enough. The size is pretty big enough, so highly polarized. So phosphorus is a good nucleophile. Attack carbon there. So bromine comes out, just regular SN2 attack. Okay. We get a phosphonium salt. And the proton next to the carbon next to the phosphorus, I'll make sure you guys look at that carbon, okay? The protons on it is pretty acidic, right? If you remember the alpha proton, pK about 20, now you can remove this alpha proton by adding some bases, okay? And the proton right here is actually acidic, all right? You can remove it using N-butyl lithium, or any type of base down here. Sodium hydride works. We have alkyl lithium, and butyl or phenyl lithium works. Sodium amide also works. Okay, but I'm going to use the popular one is N-butyl lithium. So butyl and lithium form a covalent bond, just like Grignard reagents. See, treat this guy as a Grignard reagent. Butyl group, the butyl group got a negative charge. That will go dipronate. that alpha proton. Okay, that's how you make Ylide. This Ylide is resonance stabilized by phosphorus. I'll take a look. You can draw that right there. Some of you think, hey, hold on. You just move electron to phosphorus, nothing come out. Well, phosphorus is on third period in the periodic table, so I got d orbital, and that's this electron fit right there in the d orbital. Okay. And you cannot make Ylide from tertiary alkyl halide because the first step had to be SN2, just steric hindrance. All right, that's the mechanism. That's how we make Ylide. Now, let's take a look how we use it. Okay, on the next video.